Hi, everybody. For those of you who were absent the day we went over periodic reasoning and we did some group work, I've created this video to kind of catch you up a little bit or up to speed. Before I get started, you need to make sure you have two things, and that is a pencil and your science notebook. You should be in quarter 2 and on number 1 on your paper in the table of contents, and please title that periodic reasoning. All right, so we are going to get started, and I'm going to give you a little bit of background information on the periodic table and kind of where it came from, why it's set up that way, and we'll go from there. So the first thing I'm going to pose to you is, what is dihydrogen monoxide? It sounds like this really freaky, scary chemical. So I'm going to give you some background information. So just kind of sit and listen for a second. It says dihydrogen monoxide is a colorless, odorless, tasteless, and kills uncounted thousands of people every year. Most of these deaths are caused by accidental inhalation of DHMO, but the dangers don't stop there. Prolonged exposure to its solid form can cause severe tissue damage. Dihydrogen monoxide is a major component of acid rain. It contributes to the erosion of our natural landscape. It corrodes and rusts metals. In addition, it's found in every stream, lake, and reservoir in America today. In addition, it has even been found in Antarctic ice. The danger doesn't stop there. In addition, it's an additive in certain junk foods and other food products. After listening to all of this, can you believe it that the American government has refused to ban the production of this chemical? So my question to you is, what is dihydrogen monoxide? So right here is actually the formula of dihydrogen monoxide. It is H2O. Does that sound familiar? It probably does, and it probably sounds, or if you know anything about H2O, you know that it's water. So this chemical that I was talking about, dihydrogen monoxide, I was actually reading about water. So I'm just going to go through a few pointers just to point out. So is water a major component of acid rain? It sure is. Can the solid form cause severe tissue damage? Yes, ice can cause frostbite. Does water erode our natural landscape and rust and corrode metals? You got it. Is water found in every stream, lake, and reservoir in America? It sure is. So why am I giving you all this information about H2O or dihydrogen monoxide? I'm giving you this information because I want you to understand that sometimes these chemicals that they use or you read or hear about might be scary, and sometimes they're not. The other thing is, when you see H2O, I want you to understand what is the H and what is the O, and that's kind of where we're leading today, and we'll talk about. Before we can do that, though, we need to kind of go a little bit smaller than the H and the O. H meaning hydrogen and O meaning oxygen. And those are all part of the periodic table of elements. Well, before I can talk about elements, I need to talk about something smaller than that, which is an atom. So my question to you is, what is an atom? An atom is, think about it. What I'd like you to do is pause the video and write your own definition down in your notebook. Now that you have your definition down, let's define that definition. So right below your definition, I'd like you to write mine. An atom is the smallest part of an element having the same properties of that element. After you've written that definition, can you please put a star next to it? So go ahead and pause the video so you can copy that down. Next is, what do you think an atom looks like? So I'd like you to think for a second, and I'd like you to jot your ideas down. You can have 1 or 2 drawings or describe it, whatever you like to do. Go ahead and pause the video and do that. Next, if you look at your drawing and you see these, maybe your drawing looks like one of these. In the center of your screen, you will see that this one is the middle one is the one that kids often drew in class. The one on the right we saw a few of, and the one here on the left we saw a few of those too. So, but your drawing is probably like the one in the middle, or maybe it's not like any of these, and that is okay. So right now, what I'd like you to do is draw this model that you see here. You don't have to necessarily worry about labeling 6 protons, 6 neutrons. I just want you to have like a cluster of circles in the middle and some rings around the sides with some circles on those rings. And that's about it. And you can pause the video right now to do that. So I had you draw this, and we're going to be referring back to this over the next few days and weeks when we talk about atoms and elements and molecules, compounds, etc. So this will make a little bit more sense later on. So we talked about atoms, which are all these small little particles, but they all make the elements. So for example, if I talk about gold, gold is made of atoms of gold. So all of the atoms have the same properties of gold. They are shiny, hard, solid at room temperature, malleable, ductile, and we'll talk about a lot of these properties later on next week. But all of these elements are organized into something called the periodic table. And you probably have seen something like this before. And I'm sure you either know what it means or you don't. Yeah, at least you probably have seen it before. And you can go online and Google search periodic table of elements, and you can get a plethora of different types of periodic tables, but they generally all have the same information presented on it. And that's what I'm going to discuss next. So in front of you, you have a square. This is a periodic table element, oxygen. So I said, what is this? Well, it's oxygen. That says it right there. What I'd like you to do right now in your notebook is copy this down, and then we're going to label it in a few seconds. So go ahead and pause the video. Now that you have that square, I'd like you to label the 4 parts on the side. So atomic number, chemical symbol, element name, and atomic mass. Go ahead and pause the video and write those things down. Now next to those definitions, those words, we're going to define them. So atomic number means number of protons and electrons. Chemical symbol is an abbreviation or letter code. It's sometimes either 1 letter, 2 letters, or 3 letters. If it's 1 letter, it's capitalized. If it's 2 letters, the first letter is capitalized and the second letter is lowercase. And then if it's 3 letters, the first letter is capitalized and the second 2 letters are lowercase. This is extremely important to remember later on when we talk about molecules and compounds. Element name doesn't really need a definition, and atomic mass means the number of protons and neutrons. Now I'm throwing out number of protons and neutrons and electrons. Again, this is just to give you some background information. It will come up again over the next few days and weeks in class. So for now, just have it down so we can refer to your notes. All right, well, we can't really talk too much about the periodic table without giving thanks to Dmitry Mendeleev. Dmitry Mendeleev was a Russian scientist who kind of paved the way with the periodic table. He had discovered that there were 65 elements, and he kind of wrote them down on cards. And he kind of almost like playing cards. And on these playing cards, he wrote down all the properties, things that describe them. And one of those was atomic mass. Well, he had these 65 cards, and he's needed to come up with an organization tool. And he thought and thought and thought, and finally kind of came up with this idea of and he created this table. And in the table, he saw that these elements had patterns, and he started organizing the elements by these patterns. And the periodic table kind of evolved over time and has changed over the years, and we continue to add to it. And but thanks to Dmitri Mendeleev, we can have this periodic table in a nice organized fashion that makes sense. So what your task is going to be now is to explore the periodic table. After you have explored the periodic table and looked at it, I want you to summarize it. So in your exploration, I'd like you to write down maybe 3 or 4 things that you notice about it. What kind of patterns are you recognizing? What things do they all include? Whatever you want to write down, 3 to 4 things, and then summarize it. And so you can just make a list or write in a paragraph, whatever you'd like to do. So I'm going to go to the next slide, and that has the periodic table. Once you have the periodic table up, go ahead and pause it, and when you are done, you can go continue on with the video. So the next one, my next slide is about how did Mendeleev organize the periodic table. So you kind of came up with your own list, and I want you to write down these things right now that you see on the slide. So I want you to copy the entire slide down on your notes, because this kind of summarizes why the periodic table looks the way it does. Mendeleev organized it by atomic mass, as well as the elements having similar properties. So if you need to pause the video, go ahead and do so. All right, I have 2 more tasks. The first part of that is to create an alternate way of organizing the periodic table and explain why your system works. So you have received a periodic table in class, and what I'd like you to do is organize it in a different way. So you can't copy what Mendeleev did, you can't copy what is currently existing, you need to come up with your own idea. Once you do, I need you to have a summary or a finished product, whether you cut it up and reorganize it, whatever you want to do. I'm leaving it open to you on how you present it to me. And then the second part of your task is to tell Mendeleev what you did and why. So you're going to write him a letter, no more than a paragraph, explaining why you organized the periodic table the way you did. And if you have any questions between now and the next few days when you're going through this, by all means, see me in class, or you can always email me through school email. All right, and I will see you in class.